How's it going, everybody? And welcome back to our Enterprise video series where we're going to be focusing on CCNA, CCNP, CCIE, and all that good stuff that goes along with it. I wanted to start off on a very basic implementation of networking, layer 2 switching, connectivity, stuff like that. Something that no matter if you're just getting started into networking and you're dipping your toe, literally dipping a toe in the water, and you've got basically no experience doing any of this, or you're a seasoned professional like myself, where you've been doing networking for well over a decade, and you're putting together large scale designs on a regular basis. The point being is, no matter where you're at in that 10-year journey, you should be able to do this. At least that's the goal of this video, is to walk you through the mindset. This is going to be sort of design and what to expect. What are the network operations going to look like, and things like that. So it's going to be more geared to an entry level person, but anybody that is more advanced, they're going to have these same thought processes as they're going forward. So I'm going to go ahead and zoom in a little bit, just so that it's easier for you guys to see. And I'm going to go ahead and get out of the way. So let's go ahead and pull up Secure CRT. And let's talk a little bit about what we're doing here. So we have switch 6, and the goal with switch 6 for right now is to just get PC48 and PC67 to be able to talk to each other. And that might seem very rudimentary, but at the end of the day, that's essentially all networking is using infrastructure equipment, whether it's a switch, a router, a firewall, or an access point, to allow endpoints on the network to be able to talk to each other. That's literally it. And just so everybody understands, I mentioned this in the previous video, but the PCs are switches that I've just given a different icon to, but it allows me to CLI interact with the devices. So switch 6, as we progress further, this was an easy site to get into. We have some more complicated sites up here when we get a little further along into layer 2 networking. But this will allow me to basically walk you guys through some basic connectivity here. And then as we get a little further along, we'll talk a little bit about how trunking works and how you can get connectivity between switch 6 and switch 5. And then eventually have PC48, PC67 will be able to ping R24 and R23. Now, at the high level of what we wanted to talk about is what can you do out of the gate on equipment. So the reality of that scenario is that every port on a Cisco switch by default is inside of VLAN 1. So on the blueprints, I believe they refer to that as the default VLAN. And when you Google that, the default VLAN on Cisco equipment is VLAN 1. And it usually means the default VLAN for VLAN 1 for every platform is VLAN 1. Now, VLAN 1, when they say that, it is also an untagged VLAN by default. So meaning out of the gate, without you having to do any modification to the way that the switch is configured at either the switch level or at the individual interface level, all of the interfaces are in VLAN 1, and it's untagged. And all that basically means to you is that if traffic was to traverse between switch 6 and switch 5, switch 5 would still learn the traffic, because there is no tagging done on the native VLAN, and we'll talk a little bit more about that in detail, where sometimes that's a good thing, other times it's not. So it will really depend on your individual scenarios. I've seen environments where every trunk link, let's say you've only got a couple of VLANs allowed, one of that, usually the management VLAN, is untagged. So, but it's one of those things where it's on a case-by-case basis. I wouldn't say that across the board on every switch deployment you do, you need to always think about the native VLAN. That is not the case. So just more of a be aware of what it is and how it works, and then you can make a design decision ahead of time. So I want to talk a little bit about design first, and then we'll talk a little bit about implementation, because you should always plan ahead. The what is it? The 6 P's. I listen to a lot of military podcasts, but it applies to everything. What is it? It's proper prior planning for something piss poor performance. Hold on one second. Now that I've actually said it, I want to the 6 P's. The 6 P's. No, that's for project management. No. For the 6 P's for planning. No, that's not the right one. Military. We'll talk 6 P's. Yes. There we go. Okay, so I'll bring this over just so that you guys can see what I'm talking about. It says proper planning and preparation prevents piss poor performance. So it's 1, 2, 3, 4, 5, 6, 7. So okay, yeah. So proper planning and preparation prevents piss poor performance. So that is what I was trying to think about. Sorry for the it took me a second to think. But you always want to. So it goes back to the PPDIOO, the prepare, plan, design, implement, operate, optimize. So if you keep that cycle in your brain, if you will, what's the other one? The OODA loop. One second, I'm having all these things come to the brain. The OODA loop. The OODA loop is a 4-step process, and like I said, I listen to a lot of so observe, orient, decide, act. So if you can figure out what's going on and make sure you know what you need to do and when you need to do it, you can stave off a lot of problems before they become a problem. So with that being said, the design is where we want to start first. So you'll find that you have a develop and design. So develop. Let's talk a little bit about that, right? So you have prepare, plan, design, implement, operate, optimize. So we want to prepare and plan. Prepare. What do we need? So, for example, I travel a fair amount during the summertime up north from where I live now. And when we go, we have our normal, say, 25 thing list that we run through before we leave the house to go on our trip. And sometimes I like to smoke meat. I have a Traeger pellet grill. So, for example, if we're going to smoke something up north, I will, grab the meat, make sure it's in the cooler. We'll grab the pellets, make sure we'll grab all the seasoning, stuff like that. We'll make sure to have all the things that I need for that cook to do its job, and then, off to the races we go. So the first thing that we need to understand is what is it that we're trying to engineer for. So that's why I've seen multiple times. I remember sitting for the service provider lab in Richardson, Texas, almost 4 years ago. Was it November? It was in November. November 8th, I think I took the lab. Or 9th, one of the two. Anyway, so when I was in the lab, my wife and I flew down there. When I was in the lab for the SP track, I was surrounded by people. Some of them knew who I was, some of them didn't. But it was interesting to be surrounded by all these people, and I heard just a fury of typing. like out of the gate. And I'd say the bulk of the people there were for the route switch track before they flipped over to Enterprise. It might have been Enterprise. I don't remember. And I think it was, because at that point in time, no, I hadn't taken that was before the exam flipped over. So that was in 2019. I think it flipped over in 2020. But anyway, not important. But I heard a fury of typing. I was like, wow, that's all, you know. It got very kind of loud actually in the lab, and I had to like focus on what I was doing. Anyway, not important. So what ends up happening is it's easy to type out the commands. Like I know what to type, I know where to type it, right? That the syntax, the configuration commands. I know where to type things globally. I know where to type things in at the interface level to make PC48 and PC67 be able to talk to each other. Done it thousands of times, both in a lab and a real environment, with troubleshooting scenarios, first-time deployments, rollbacks, the whole gamut. Something I'm very, very comfortable doing. So, but before I do that, we want to figure out what is it that I need to go do. So what I decided not to mark off on everything. I'm still this topology is actually still a work in progress. As you can see, I'm still doing all the interface labeling for you guys and all that type of stuff. I was like, I'm just going to start recording. I don't really want to waste 3 hours trying to get something stood up. I'm going to start recording some basic stuff. So let me go ahead and grab, duplicate. And then I'm going to scoot this guy over here, and then we're going to go ahead. I'm going to use this as our baseline of what we're going to configure. So we're going to be creating one VLAN, a very, very simple network. Again, this is geared for those that are at the entry level. So if you're like a CCNA already, or a CCNP, or whatever certification you're at, and you're like, Rob, this is super simple, skip ahead or move to the next video, whatever. So we're going to have one VLAN, and we need to come up with some information. So what size subnet do we need? How many? So there's a couple things to keep in the back of your mind. Let's think design here before we're configuring. So you and I are in a meeting, and whether I'm on site, remote, whatever, you and I are in a meeting of some type, whether it's a virtual or an in-person call, and this is a new site, so it's a greenfield deployment. It's a new site that's getting stood up, and let's say there's a handful of us. I'm leading the charge, and there might be some other folks that are more junior level to me. I'll be the senior engineer on the project, and I'm going to be delegating some work to you. So I'm talking to the people that are deploying this, the facilities, business, the business, all that type of stuff. I'm communicating with them. I need to get some information out of them so that I can formulate a plan and then pass that information on to you. You're going to own, meaning I'm going to configure it for you, but I'm going to walk you through what it is you need to know in order to make that happen. So the first question I'd be like, okay, how many users are we talking? Like, okay, so with /24. So think back to subnetting, right? Subnetting in itself, we haven't actually covered it in this series yet, but anyway, think back to subnetting. A /24 is about 250 users. That's a rough estimation, but that gives us a roundabout number. Roundabouts are okay for the most part at a high level. Now, if you're getting very close, if somebody says, well, there's going to be 240-ish users, okay. Is there a potential that this site could grow beyond 240 users? No, that's not going to be the case. This site, 240 users at maximum capacity. That's literally all we have seats for. Okay, does that include conference rooms? Does that include servers? Does that include wireless access points? Does that include the IP addressing for my equipment? Does that include the printers, phones? Like, what else is going to be here? And so these are going to be like, I would have a plethora of questions to plaster out. So like, how many? So it's going to be 240 physical seats that somebody could come in off the street, that, they come into work every day, they drive into the office, and they have to be here. Let's say this is a call center. It'd be a very small call center, but for the sake of argument, let's just say it's a call center. And where 800 numbers are going to be dialed into, and then you're going to have 200 bodies that are going to be answering calls, from 8 o'clock in the morning till 8 o'clock at night. Let's say that's a scenario. So, okay, cool. Well, if that's the case, then we need to figure out, okay, 240 people, let's say 40 of that is management. The other 200 are call center people that are actually sitting at a desk answering the phone. Okay, cool. So we have that scenario. So I have a /24 subnet. Is that going to be big enough? Well, possibly. The next question is there going to be any wireless? Am I going to have people roaming around? Am I going to have what is the call center going to look like? Is it just going to be a cube farm where everybody's got their own cube, they got their computer, maybe a couple monitors, they got a phone, all that? Is that going to be the expectation? Are they going to have a lead person where you have for every 10 agents answering the phone, you have a lead person where if that agent runs into a hiccup or something like that they got a lead person that they can hey Mikey, I need you, or something like that, or hey Bev, can you come over here? Are they gonna have somebody that's walking around with a laptop or a all-in-one type of situation, like an HP where you can flip the laptop screen backwards so it goes from laptop to tablet? Are you going to have something like that where we need wireless? Are you going to have the ability for a voice over wireless? Does the lead person have an ear like a Plantronics headset that they can for example, I've seen this a couple times in call centers where the agent is able to transfer the call or add the lead person in as a third person on the call. So what is that going to look like? I know I'm getting kind of deep into this, but these are some things from a networking perspective you and I would need to figure out. So let's say, for example, that is the case. So 240 users is going to be in the building. 200 of that is going to be agents. The other 40 are going to be leadership of some type, a lead person, a supervisor. You're going to have maybe a manager, director, so some big wheels here. So 40-ish people are going to be leadership that aren't going to be answering the call, but still need to have a device of some type. There's going to be wireless. So even though a /24 will get everybody covered, how many servers are going to be on site? What are those servers going to be doing? Phones. So you got to figure for every IP address, and then are these soft phones or are they hard phones? Are we going to be doing, whether it's Cisco, Avaya, whatever, 3Com, all of those different vendors, that piece right there, I don't care who the vendor is, I care about endpoint information. So automatically, let's say for example, yes, we're going to have wireless, that in the event that people need to move around, we're going to need a wireless subnet. Okay, cool. So we take that into consideration, right? So let me go ahead and do this. So for LAN, we're going to need 240, right? And then for Wi-Fi, we're going to need, let's say, half that. We're going to need 120. So, because not everybody's going to need Wi-Fi. So I'm literally, as I'm thinking through this, okay, are agents on their break going to be able to walk to the break room and use the Wi-Fi to surf the internet? Maybe local cellular service is not that great. So let's say, for example, okay, let's say 240. So for every person that's there that's got a cell phone, they're also going to need to have Wi-Fi access. They'll have a guest network and things like that. Okay, cool. What about servers? How many servers are we going to have? Well, we don't know. How are the agents that are logging into these systems making, taking user requests or complaints or whatever it is that they're fielding calls for, what are they, what system are they interacting with? Is that service a service that's hosted in like Azure or AWS, or is that something hosted locally? What does that look like? So let's say, for the sake of argument, we're going to say there's going to be 50 server IPs, whatever that might look like. The next is going to be phones. I'm going to put in here VoIP. So this is going to have to equal out to 240, right? Because everyone's going to need a phone. Okay, so just that information alone right there, we've gone way beyond two endpoints when I configure this, right? I just, trying to give you that conversation of how something as small as this small site can, quickly get exacerbated, and you have to figure all these things out. This is a very, very common topic of discussion when you're figuring network design. And this is a basic site, right? There's nothing complicated about it. It's very small. So there's that. Okay, cool. So now that I have all that, let me take a moment and let's talk about port count. How many ports do I need? Well, I've got, for every IP, you're going to need a port, right? So I've got 240, 240, 240. So let's say 250, 500, 750, 800 ports is what I'm going to need. So of that, so let's go ahead and pull a calculator up. Let's talk a little bit about how that would work. Let's do a port density calculator. So I'm not going to play around with 24 port switches. So I'm going to take 800 and divide that by 48. So I'm going to need 16 switches on average. 17, let's say 17 switches is what's going to be needed in order for that to work. Now, are they all going to be the same type? Probably not. So for the sake of argument, I'm going to say 700 of those ports, 250, 250, no, actually take that about 750 of those ports divided by 48, that'll give me 15 switches. So that means so how would you break that up? Well, what I would normally do is I would break that up into these are going to all be access layer, by the way. So the real look and feel is going to be more like this, where you're going to have a distribution and you're going to have several access, or something more like this over here. It's going to look more like this. Hold on. Where you have distribution, you have several access switches, right? It's going to look more like this physically than it will this, right? But it's a small site. So we got that. So we had that to consider as well. So we're going to need 16 switches, 16 user switches, and then we're going to need, at a minimum, we got 50-ish servers. So that means we're going to need 2 data center class switches. So I would say 2 Nexus switches. So that would be essentially what we would do. So now you take all that information that you have so far, and so let's say, for example, we're going to be using, hopefully the numbers equal out on that, so we're going to need 16 Catalyst switches and 2 Nexus switches. So that's going to be a total of 18 switches that are going to be deployed to this location, just to do the bare minimum. LAN, Wi-Fi, voice over IP, and some servers, right? Pretty simple stuff, right? Well, simple in terms of the thought process, right? So let's go ahead and figure out, okay, what is the subnetting going to look like for this? So I'm going to go ahead and for this site here, so we have these users, just so we have the contextual information, we're going to go ahead and let me go ahead and, there we go. Let me go ahead and blow this up. We're going to say it's going to be 172.31. And I'm going to start out with something simple. I'll do 0.0/24. That's going to be that one. That's going to be our LAN subnet, 172.31.1.0/24. And then we're going to have, let me go ahead and move VoIP to here. This is 172.31.2.0/24. And then the server subnet, I'm going to put here 172.31. And I'll put in, I'm going to leave room for growth for both LAN and for Wi-Fi. And now that actually, now that I'm thinking about that, my brain automatically goes, well, yes, I'm allocating basically 3/24 to this location, but is that going to be enough? Well, there might not be any more physical seats for people to sit down in. So, and then you ask, okay, you got picture a very very large room that's open, right? It's an open open floor plan, I guess you could say. You've got this open floor plan that you're looking at, and you've got this cube farm, 200 users. Let's say you've got, I don't know, whatever that looks like. I'm not trying to like draw it out completely, but to paint a full picture for you. So you might only be able to get 200 seats, and this is a full call center, right? It's wall to wall. You've got a sea of people answering the phones. Now you take that conceptually, and even though you might only have 200 agents at any one point in time answering calls, maybe it's 20 rows of 10, something like that. So you have that. What about conference rooms, right? The conference rooms where you'll, have people come in off the street that are, I say people off the street, but you'll have consultants. You'll have people that are traveling into that location that don't normally work there, stuff like that. So is 240, is that going to be enough? And, you're going to have ports inside the, you're going to have phones inside of the conference rooms. You're going to have computers inside the conference room, stuff like that. Normally speaking, you're not going to run you might have a couple of physical RJ45 or Cat6, Cat5e terminations in a conference room for dealing with the phone, so that the phone's on the network, and then you also have like a you have big TV, so you might have some sort of connection like that working. So those things might come into play. But most of the time, when people are in a conference room, they need power and they need Wi-Fi. So you might have an AP on the ceiling, just that might be narrowed down inside of its RFs, its BSSID, to its basic service to just handle that particular conference room. Well, let's say, for example, that is the case. So LAN, physical LAN ports, 240, that might be enough. That might be IP address wise. However, Wi-Fi, I don't think that's going to do it. I think you're going to be beyond 240. I'm going to say, for the sake of argument, that we're going to need to go beyond that. So we're going to come in here, and this is going to be 1 and through, this is going to be a /23. So we're going to Wi-Fi a whole 512 IPs. That's what we're going to give. We're going to around 500. We're going to have plenty of Wi-Fi access. It's a /23. Everybody's happy. So now that's one big blanket for a wireless network. And the reality is most wireless networks are not going to be that wide. We're not talking hotel stretch. You're probably going to break that down into multiple different SSIDs. You're going to have a guest SSID for people that come in off the street and stuff like that. You're going to have a corp SSID. You're going to have user SSID, stuff like that, where a laptop that comes on the network, it's going to go ahead and jump on a particular SSID. You're probably going to have single sign-on through AD authentication, a whole bunch of other things behind the scenes that are kind of outside of the scope of what I want to talk about in this video, but you get my point, right? You need it's not 240 for the 200 agents plus the managers, and then you have people coming off the streets. You might have a vendor, you might have you'll have potentially more than 240 people at the site. But because of the way that subnetting works, could you give it a different subnet for like guest? Yes, you could, 100%. But for the sake of argument and to keep things simple, I'm going to say that we're going to give them a /23. And then, so it's going to give us 0 of 172.31.0/24 will be for LAN ports, all the physically wired stuff. 172.31 1.0 through to 255 will be our wireless network. And then 172.31.3/24 will be our VoIP for all our physical phones. And then servers we're going to go ahead and give him, we'll give him 4.0/25. We'll give him the first half of that subnet range. Now, could we add more in later? Sure, you can add more in later. So that is going to be our subnetting. So now that I have that, what does that give me? That gives me some stuff that I can go do. I know I'm going to have at least 4 VLANs. I know the subnets that those VLANs are going to be applied to, and all that good stuff that goes along with that. So I know this was supposed to be a very simple implementation. It's still going to be. The actual configuration that we applied to switch 6 is going to actually be very, very easy configuration-wise. However, it's the what is actually needed at this site in order for it to make it happen, and all the stuff that we're going to go along with. Now, all I'm going to do is I'm going to configure all the VLANs on the switch, and R24 and R23 are going to be the default gateways for that. And for the simplicity of like understanding how VLANs work, how trunking works, which we'll talk about in the follow-on video, we're going to just allow, we're going to configure these guys 172.31, but on this over here, I'm going to have all 4 of these subnets configured on R24 and R23, so that if I wanted to ping, for example, from somewhere else to R24, the ping would go through. So the reachability would be there. The subnetting itself is, I don't have enough icons and stuff like that to be able to make an environment that size actually become realistic. So instead of doing that, I'll just configure, gig 00 with sub interfaces, because we'll do router on a stick. We'll do layer 3 switching up here so you guys can see the difference between the two and stuff like that. So fairly straightforward in that regard. So with that being said, let's go ahead and pull up Secure CRT. And on switch 6, I'm going to go ahead and, again, this is a greenfield deployment, which means nothing's been configured. You and I are going to go do this. So once I have this information, I've kind of jotted down some of these notes and taken, answered got some questions answered. I would then focus my attention. So I'm going to name you subscriber, just because of the fact that you guys are watching the video. I'll say, and I don't know who's going to be watching, what your names are, so I'm going to sit there and try to rattle off 70 names. So I'll say, okay, subscriber. Here's what we're going to go do. This is going to be your action items for this. I might even, other person might have already left the room, so it's just me and you left to have this conversation to figure out what we're going to go do. So here's what I need you to go do. I need you to come up with 5 subnets. So we need 5 subnets for all the connectivity, and I've already laid that out, what the subnet ranges are going to be, because I've already got a block of addresses that I've already gotten from IPAM, IP address management, to associate to this site. We just need to figure out, we got a /16 or /20 or something like that. So we have more than enough IP addresses than we're ever going to need. It's just one of those things where we, if you don't need them, then so be it. But anyway, so we're going to do that. We're going to configure the four VLANs, and the 4 VLAN names are going to be as you see, right? We're going to the names are going to be what you see here, and I need you to configure switch 6 is going to be an access switch. Switch 5 is going to be a distribution switch for the sake of argument. Both switches are going to both need to have all the VLANs applied to it, and then R24 and R23 are going to be the gateways, and we're going to need to configure .1Q sub interfaces for doing router on a stick. Gig 01 and Gig 02, these guys will need to be configured as access ports, and we'll be doing spanning tree port fast. We'll do voice VLAN, all that good stuff that goes along with that. So which VLANs? Oh, that is a great question. I didn't even think about that. Which VLAN IDs are we going to be using? So I'm going to go ahead and say, for the sake of argument here, LAN 240, I'm going to say we'll use 310, 311, 313, 314. Does that work for you? Perfect. So we're going to use, I'm going to pull this out here. This is going to be 310, or VLAN 310, VLAN 311, VLAN 312, oh sorry, 313, and then this will be here, VLAN 314. Cool? Any objections? So are these, and I'm trying to make up questions as we're going along. So do we need to worry about these VLAN IDs anywhere else? No, we don't. VLAN IDs can be used, the same VLAN ID can be used everywhere, right? So you could use VLAN 313, 312, 316, 310, 311, whatever, over here at this site, over here at this site. VLAN IDs themselves are locally significant to the site, unless you're trying to stretch them over a WAN circuit via good old-fashioned spanning tree, and we're not going to do that. I'm going to do some VXLAN down the road with you guys, and we'll see what that looks like, but no, we're not going to need to worry about that. It's the subnets, the actual IP addresses attached to those subnets, that we're going to have to go through and be cognizant of. We can't have overlapping subnets, but we can have overlapping VLAN IDs, but good question. So that is something I've gotten quite a few times. Okay, clear? Awesome. So let's go ahead and begin configuring this. So this is the configuration that we're going to use. I'm going to go ahead and get out of the way. And we're going to go to global config. I'm going to type in here, this is going to be, host name is switch 6. And then we're going to say VLAN 310. Name is going to be LAN. VLAN 311. And that slight hesitation, I don't know if you caught it or not, is the actual VLAN being created. We're going to call this here the Wi-Fi. VLAN 313. This one here is going to be, name is going to be VoIP. And 314, this is going to be servers. Okay? So do show VLAN brief. There's our VLANs created. Everybody's happy. So now I'm going to go to interface range gig 0. I'm sorry, let's do this in one at a time. So interface gig 0/1. I'll type in here switch port mode of access. And I'm going to type in switch port. It's going to be access VLAN 310. And I'm going to say switch port if you've got, and normally what would end up happening here is a phone, a physical phone, is going to have 2 ports on it. You're going to have a port that comes from the switch that provides the PoE, the power over Ethernet, to power the phone on. And then there's going to be another port on it that's going to connect to the PC itself. So don't worry about what you're seeing there. I'll come back to that in just a moment. Okay, so just for a visual, so I happen to have a handful of Cisco 9971 IP phones. This is a little bit dusty. It's been sitting in my closet in my office for a while now. It does have the ability of doing video on it right here. This video screen does pop up, and it's got like 480p or something like that. So what I'm talking about for a visual reference is back here. Put the handset back on here. Is right here. So if you were to, can this? So where my hand is, right there, we have these 2 ports, and so the one right next to my finger, this guy right here, let's see if I can get that guy right there. Actually, one second, there's a better way of doing this. There we go. So this one right here, I don't think it's going to get any better than that. Oh, there we go. So this one right here is the one that connects to this switch port, the switch. This is where your PoE comes from. And then this one goes to your computer. So you would have a connection come in from the switch to this guy, and then this guy here would go out to the computer and provide the internet connectivity, network connectivity to the computer. So all of your computer's data would actually pass through the phone switch port, or the switch that's right here, and then go to wherever it's got to go. So pardon me while I pause. Okay, now that we've talked about how the phones work and that connects in, there's going to be a phone sitting in between the PC and the switch port. So what I'll need to do here is type in voice VLAN is going to be, what did we say, 311. So what that voice VLAN does is when the phone powers on, the phone's going to get power regardless. It's going to get the it's going to get a PoE notification for this switch isn't going to do it here. Actually, 1 second here. This one should do it. This is my home switch. This is a 3750X. So I do a show CDP neighbor. I have an access point. We do show power inline for gig 109. You'll see that I have right here. This is what you'll see on the switch. You'll see how many watts of power is getting pulled in. It's on. It's pulling class 4 power. It's pulling 16.8 watts of power to power on the AP. Now, if I had Cisco phones, they would be, or phones in general, they would be showing up here as well. And if I did a show CDP neighbors, they would show as SEP for Celsius Ethernet phone. So SEP plus the MAC address. And how that works. So that's essentially what you would need to be worried about. But I'm going to go ahead and close that out. So we have, I'm not too worried about this right now. We'll talk about that here in just a minute. So now that we have this done, and we're going to continue to get the VLAN mismatch on there, which is no big deal. So the you might say, well, why am I seeing that? Well, that's because PC48 and PC67 are switches as well. So we're just going to have to go configure those connections on the remote side. But I'll take care of that in just a moment. So we have that configured. Everybody's happy. So now that I have that, if I do show run interface gig 0/1, that's the syntax so far. I have switch port access VLAN 310, switch port mode access. The voice VLAN is 311, RJ45 is the media type, negotiation is set to auto. So I'm going to type in here, I'm going to say switch port, or sorry, spanning tree port fast. I want the listening and learning states of spanning tree to be bypassed immediately for this type of a device because it's automatically going to go into, what do you call it? It's going to go into forward. It's an endpoint, meaning that there's no switches behind it, which is technically not true in this case here, but I'll fix that here in just a minute. So that's essentially where we're at there. So now we've got that piece understood. I'm going to go ahead and do the exact same thing. I'm going to do show run interface gig 0/1 again, and I'm going to say interface gig 0/2. I'm going to do the exact same thing. I'm just going to take all this configuration right here, and I'm going to paste it down there to make it just gets the configuration done faster. Normally you do this in the range command. Once you have a template of the configuration you want configured, built, 8 or 10, 15, 20, 30 commands or whatever it might be, you would then go do an interface range where you configure gig 1 through 48, and you would just mass configure all those interfaces for an access switch. It makes it very, very simple. So now that that's done, let me go ahead and get out of the way. Let's go to PC48, and you can see where between these two, if I was to do a show CDP neighbor, it's seeing switch 6 because it thinks it's a trunk. So what I'm going to need to go do is on this side here, I'm going to type in host name is going to be PC48, do show IP route. I'm going to type in no IP routing. That turns routing off. And then I need to go to interface gig 0/0 and type in no switch port to turn it into a routed port. So I'll type in here. So now we should stop seeing all of the CDP stuff on this side. That should start going away. Now gig 02 will start saying it because now we've got PC40 because I've configured gig 02 as well. So we should stop seeing that information popping up on switch 6. So I'm going to type in IP address here is going to be 172.31.0. Let's say 48, and we'll say a /24 mask. Okay, do show IP interface brief here. Okay, that's good to go. So I'm going to go ahead and let's see, PC switch 46, switch gig 1. Oh, gig 1. Okay, gig 1 is PC67. I'm configuring gig 02 at the moment, so we're good now. So I'm going to say do save. And I'm going to go to PC67, do the exact same thing. I'm going to go to global config. Host name here is going to be PC67. I'm going to type in the no IP routing, and then we're going to go to interface gig 0/0, no switch port. And so the IP address here will be 172.31.0.67/24 mask. So that's basically what we need to do there. Do show IP interface brief. Perfect. I'm going to save that config. I'm going to go back to PC48. I'm going to go back over here. We stopped seeing those native VLAN mismatches now because we don't have a competing connection. If I do show CDP neighbor, I can see PC67 and PC48 showing up on those ports. If I do a show MAC address table dynamic, I can see traffic from both devices showing up at VLAN 310. Now, what I'm going to go do is I'm going to take this a step further. I'm going to go to interface gig 0/0. I'm going to type in MAC address. MAC-address is going to be 0000.0310.0048. And I might have to bounce that interface. So if I go back to switch 6, yes, so this should go away. So if I was just to go to shut that interface down, and then no shut it. Yeah, it's okay. This particular MAC address will eventually age out, so goes back to talking about the MAC address timing or the MAC aging timer, and how it's a 5-minute timer, so it'll keep the MAC address in the database for 5 minutes. So just so you're aware of that. So I'm going to go to PC67. I'm going to say MAC-address is going to be 0000.0310.0067. I'm going to save that as well. So switch 6 should see that as well. So we're going to have multiple entries. I'm going to do this. Interface range gig 0/1 through 2. I'm going to shut. So I'll just bounce the interfaces. This will flush the MAC address table. And then we'll say no shut. Perfect. Come down here. And so the MAC table is now been cleared, and we can see that the new MAC addresses are showing up. So now I want to be able to communicate back and forth between 48 and 67. I'm going to go to 48. I'm going to jump out of global config. I'm going to say ping 172.31.0.67. So it's going to ARP for it. And it should. Did I? Okay, let's see what's. Let's see. Can I ping myself? Yep. 67. The 67 see the communication. Show ARP. Yeah, it doesn't see the communication coming from switch 6. Okay. Switch 6 though definitely sees it, which is good. Why is 67 Can I ping the other way around? Ping 172.31.0.48. Show ARP. Show MAC address table dynamic. We see communication, so they're both talking to each other. Incomplete. Okay, so we have unidirectional traffic. So this guy show ARP. So he sees the MAC coming across. This guy does not. So let me bounce this interface. So interface gig 0/0. Let me go ahead and shut him down. And then no shut. There it goes. That's what I figured. Now 48 and 67 should have, there we go. That was the problem. So if there's ARP entries that are showing up as incomplete, when you see stuff like this, a lot of times, especially in a virtual lab, and even in the real life, I will just go ahead and flap an interface to see if that doesn't fix the problem. Because I'm like, they're acting like routers. Like, I've got no gateway set on them, which we'll have to set in a future video. But just so that we understand the context behind this, for getting the basic communication up and running, that's going to be the basis of how to troubleshoot that type of stuff. When I saw incomplete in the ARP table, I'm like, okay, we'll just flap the interface and clear it and bring it in. So now that I can talk back and forth, being able to ping is a good thing. Going back and forth, we'll continue to do that. So if you guys have any questions for me, leave a comment in the comment section below. Please like, share, and subscribe. And before I send you guys off with at the end of this video, this is going to be, for the bulk of what we go through, this is going to be the format that I'm going to go with, where it's going to be, isn't necessarily going to be super specific to a bullet entry on a blueprint so that you can check a box and say, yes, I understand how this works. If you're going for certification, I highly encourage that you actually do that, or you download the exam blueprint and that you actually, like, you study whatever it is, you understand how to implement it, how it works, all that good stuff. And then from there, you circle back and you can articulate those details and you know what they are. That's really, really important. So, but in this case here, I'm trying, my attempt is to focus on helping you guys understand the technology, the design behind it, the where, the why, the how, the what, all that good stuff that goes along with it, and then be able to implement. So the configuration commands that have been put into play in this video, I will copy out and I will have available for those to download if you want access to the evng file and the individual config file, so you can do the before and after. That will all be available for you guys to download if you'd like to do so. If you're a member, you'll be able to download that and go from there. So if you guys have any questions, again, leave a comment in the comment section down below. Please like, share, and subscribe, and I'll catch all of you in the next video.